Hello, and welcome. Wherever you are listening from right now, allow yourself to pause for just a moment. The day does not need your attention anymore. If you enjoy calm, science-based stories that explain how the universe truly works, gently, clearly, and without speculation, take a second to subscribe. It helps this channel continue creating quiet journeys through real science, designed for rest as much as understanding. Now let your breathing slow. Tonight, you are following a simple question. Not a dramatic one, just a quietly unsettling one. Everything around you feels limited. Rooms have edges. Horizons end. Distances feel measurable. And yet, according to modern physics, space-time itself has no edge at all. There is no wall, no boundary, no place where reality stops. So why does it feel as though it should? You are not here to imagine. You are here to understand, calmly, carefully, guided only by observation, measurement, and well-tested theory. As you listen, let curiosity stay awake, and let the rest of you slowly drift. We begin in the most familiar place possible. The way reality feels to you right now. You begin in the most ordinary place imaginable. You are aware of the room around you, of walls that hold their shape, of a ceiling that rises only so far, of a floor that reliably meets your feet. Even with your eyes closed, these limits remain clear. Your mind knows where the space ends, because it has learned this pattern over countless quiet repetitions. As you rest, you notice how naturally you measure distance. A few steps to the door, a short reach to the light, a familiar stretch of space that never surprises you. Your brain builds these measurements automatically, using sight, movement, and memory together. This skill keeps you safe and oriented. It helps you navigate the world without effort. Beyond the room, the pattern continues. Streets have edges. Buildings rise and stop. Fields open outward until they meet a line you call the horizon. You know from experience that if you travel far enough, something always changes. A road curves. Land turns to water. Day gives way to night. Endings are everywhere and they feel dependable. This expectation of limits is not philosophical. It is biological. Your nervous system evolves to understand environments measured in meters, minutes, and lifetimes. Neurons map space by tracking movement and comparing it to stored memory. Distance becomes something felt through effort and time, not something abstract or infinite. When you look out at the horizon, it feels like a boundary. The land appears to stop where the sky begins. Yet you also know, calmly and without confusion, that this edge is only visual. You understand that the surface of Earth curves away, carrying the ground beyond what your eyes can reach. Still, the feeling of an edge remains. The impression is strong, even when knowledge disagrees. This quiet conflict between perception and understanding follows you everywhere. You experience the sun as rising and setting, though you know the planet is rotating beneath it. You feel still, even while Earth moves through space at enormous speed. Your senses report one story. Science reveals another. The feeling that space itself must end somewhere grows from this same foundation. Everything you directly experience occupies a finite volume. Objects have surfaces. Rooms have corners. Even the sky, to your eyes, forms a dome that seems to enclose the world. Long before telescopes or physics, this impression shapes how humans imagine the universe. Modern neuroscience explains why this happens. The brain does not represent infinity well. It relies on bounded maps, built from repeated exposure to similar scales. When a space grows too large to explore directly, the mind compresses it into something manageable. Vast distances blur into concepts rather than sensations. You can notice this even now. Try to picture 1,000 kilometers. The image feels vague. Now imagine 1,000,000. The number increases, but the sense does not. The mind substitutes symbols for experience. This is not a flaw. It is a practical adaptation. Because of this, unbounded space feels unsettling. Without edges, the brain loses its reference points. There is no frame to anchor position or direction. Finite spaces provide comfort because they allow prediction. You know how long it takes to cross them. You know what happens at the other side. Science begins gently by acknowledging this human starting point. It does not demand that intuition be erased. Instead, it shows where intuition applies and where it quietly stops being reliable. The everyday sense of limits works perfectly at human scales. It simply does not extend to the largest structures of reality. Astronomical observation slowly reveals this difference. When you study the sky carefully, you find no visible boundary to space itself. Stars fade with distance, not because space ends, but because light weakens as it travels. Telescopes show more, not an edge, but a deeper field. Even so, the feeling persists. Somewhere, it seems there should be a final wall, a last surface, place where nothing continues. This expectation is emotional rather than scientific, shaped by a lifetime of enclosed experiences. As your breathing settles, you allow this tension to exist without resolving it. You recognize that feeling limited does not mean reality is limited. It simply means your senses evolved for a different task. And in that quiet recognition, curiosity begins to replace certainty, opening space for understanding to grow without urgency. This realization does not require effort. You do not need to force your mind to imagine infinity or abandon familiar instincts. It is enough to notice how perception operates. Your experience is local, immediate, and grounded in survival. Reality, however, does not organize itself around human comfort. When early scientists begin measuring space, they rely on geometry rather than sensation. Distances are calculated through angles, shadows, and motion. The results do not depend on how large space feels, only on how light behaves and how objects move. Over time, these measurements consistently show extension without termination. You can sense the calm logic in this approach. If space has an edge, it would need a physical property that marks it. There would be observable effects, distortions, or reflections. Careful observation finds none. Space behaves the same in every direction examined, as far as instruments can detect. This uniformity is subtle but powerful. It suggests that limits belong to perception, not to the structure being observed. Your mind expects enclosure because it evolves inside it. The universe offers no such reassurance. As you rest with this idea, there is no need to resolve it fully. The feeling of finiteness remains, gently held, while understanding expands quietly around it. The night holds both without conflict, allowing thought to soften and curiosity to remain awake in a calm, steady way. The awareness settles without strain. Breathing remains slow. Thought remains light. Reality does not press for resolution. It simply exists, extended and consistent, inviting understanding at its own quiet pace, far beyond the small but meaningful boundaries that shape everyday experience. You rest, knowing learning unfolds gently, without urgency or fear. You are always aware of space, even when you are not thinking about it. As you lie still, your mind knows where your body begins and where the surrounding environment rests. This awareness feels effortless, but it is the result of constant, silent processing inside your brain. Space is not something you sense directly. It is something your nervous system carefully builds. From the moment you begin to move as an infant, your brain starts learning relationships between motion and outcome. A small reach brings an object closer. A longer movement carries you farther across a room. Over time, these experiences form patterns. Distance becomes predictable. Space becomes reliable. You do not need to calculate it. You simply know. This knowing comes from networks of neurons that track position and movement. In the brain, certain cells activate when you occupy a particular location. Others respond when you face a specific direction or move a certain distance. Together, they create an internal map. This map updates continuously, adjusting as you turn your head, shift your body, or take a step. These internal maps are precise at human scales. They work well in spaces you can explore with your senses. Rooms, paths, buildings, and landscapes all fit comfortably within this system. Your brain evolved in environments where knowing where you were and where you were going meant survival. The scale was always limited, and the limits mattered. Because of this, your sense of space is deeply tied to action. Distance feels different depending on effort. A short walk feels near. A long journey feels far. These impressions are not measurements in meters or kilometers. They are impressions built from time, energy, and memory. Space becomes personal and embodied. You can notice this now. Imagine walking across a familiar room. The space feels small and manageable. Now imagine crossing a large city on foot. The space feels heavy and extended, even if you know the distance numerically. The brain does not respond to numbers. It responds to experience. This is why very large distances feel strange. When you hear that a star lies many light years away, the phrase carries information, but not sensation. Your brain has no lived reference for light traveling through empty space for years. It substitutes the concept with abstraction. The distance becomes symbolic rather than felt. Neuroscience shows that when space exceeds familiar scales, the brain compresses it. Vast areas are simplified into single ideas. The difference between extremely large distances becomes difficult to sense. This is why infinity feels indistinguishable from merely enormous. Both exceed the limits of embodied experience. The same process applies to boundaries. Your brain expects space to end because every environment you navigate does. Even open landscapes eventually change. Forests give way to fields. Shores meet oceans. There is always a transition. These transitions become mental markers, reinforcing the idea that space must resolve somewhere. When this expectation meets cosmology, discomfort can arise. Science describes space as continuing without a detectable edge. There is no sensory signal for this. No neural map evolved to represent it. The brain searches for closure and finds none. The result is a quiet tension between understanding and feeling. This tension is not confusion. It is a mismatch between scale and biology. Your brain excels at interpreting space that can be explored through movement and vision. It is not designed to intuit structures that span billions of light years. That task belongs to instruments, mathematics, and careful observation. You can feel the difference when you compare maps. A city map feels intuitive. You can imagine routes and landmarks easily. A map of the universe, however, resists this familiarity. Galaxies appear as points. Distances stretch beyond comprehension. The map becomes informational, not experiential. Yet the brain adapts as much as it can. With repetition, concepts become calmer. Terms like orbit, distance, and expansion begin to settle. They may never feel natural, but they stop feeling threatening. Understanding does not require comfort. It requires consistency. As you rest with these ideas, you recognize that perception is a tool, not a judge of reality. It tells you what matters for living, not what exists at every scale. Science complements perception by extending knowledge beyond sensation, using evidence rather than intuition as its guide. This understanding allows you to relax the need for space to behave familiarly. It does not need to feel bounded to be real. It does not need to match your instincts to be trustworthy. The universe is under no obligation to align with human expectations. Your mind can hold this gently. There is no need to force comprehension. It is enough to see why limits feel natural, and why those feelings do not define the structure of reality. Awareness itself becomes the bridge between perception and knowledge. As breathing slows, the idea settles quietly. The brain understands space in the way it must, shaped by survival and experience. Beyond that, science continues the work, measuring what cannot be felt and revealing patterns that perception alone could never reach. The calm grows from knowing that not all understanding needs to be sensed to be true. You lift your attention upward, as humans have done for as long as memory reaches. Long before written language, before instruments or equations, the sky presents itself as vast, patterned, and unreachable. Stars rise and set. The sun returns each morning. The moon changes its shape with steady rhythm. These motions are among the first regularities ever noticed. To early observers, the sky feels close. It appears as a dome arching over the land, enclosing the world in a great curved surface. There is no sense of depth, only placement. Lights are fixed to the surface, moving in orderly paths. The idea that space extends far beyond this visible layer does not yet exist. This understanding grows from direct experience. Without tools to measure distance, brightness becomes a guide. Brighter objects feel closer. Dimmer ones feel farther away. The stars do not change their relative positions, reinforcing the sense of a fixed celestial shell. Earth, solid and unmoving beneath the feet, seems naturally central. Over time, careful watching reveals patterns. Certain stars trace familiar shapes. These groupings become markers for seasons and navigation. The sky turns into a calendar and a compass. Knowledge grows not through speculation, but through repetition. When something appears again and again, it earns trust. Gradually, records begin to form. Ancient astronomers note positions, risings, and settings. Eclipses are observed and predicted. The sky remains mysterious, but it becomes dependable. This dependability suggests order rather than whim. Even without understanding causes, humans recognize consistency. As centuries pass, questions sharpen. Some lights wander against the background stars. These wandering objects follow paths that repeat but resist simple explanation. Careful tracking reveals complexity. The heavens are no longer perfectly uniform. There are layers of motion to be understood. Mathematics enters quietly. Geometry provides a way to describe angles and positions. Distances remain unknown, but relationships become measurable. By comparing angles between stars and the horizon, observers infer structure without touching it. The sky begins to transform from surface to system. One of the most important shifts comes with the realization that Earth may not be central. Models change slowly, tested against observation. When predictions fail, adjustments are made. This process is patient and conservative. Ideas survive only if they match what is seen. As instruments improve, measurement deepens. The invention of the telescope changes everything. Objects once thought to be points reveal structure. The moon shows mountains and shadows. Planets display disks and phases. The sky is no longer smooth. It has texture. These discoveries weaken the idea of a nearby celestial shell. If the moon has landscapes, it must be a place, not a light. If planets show phases, they must move around a source of illumination. Distance enters the picture, not as feeling but as inference. The stars remain stubbornly distant. Even powerful telescopes fail to show their movement relative to one another. This absence of detectable shift suggests immense distance. Space, once thought shallow, reveals unexpected depth. The universe quietly grows larger without changing how it looks to the eye. Measurement becomes the key to expansion. By observing tiny changes in position over time, astronomers calculate distances to nearby stars. These changes are small, barely detectable, but reliable. They provide the first true scale beyond the solar system. With scale comes humility. The sun becomes one star among many. Earth becomes one planet among several. Familiar centrality dissolves. Yet the process feels calm, not dramatic. Each conclusion follows evidence, not imagination. As techniques improve, distance ladders form. Nearby measurements anchor farther ones. Brightness becomes a tool, not a guess. By comparing known objects to distant ones, astronomers extend reach across the galaxy. The sky opens layer by layer. Throughout this transformation, one thing remains consistent. No boundary appears. Every time instruments improve, more space reveals itself. The edge retreats without resistance. This pattern repeats across centuries, suggesting something profound. The absence of limits is not accidental. The measured cosmos replaces the ancient sky without erasing it. The same stars remain, but their meaning changes. They are no longer decorations on a surface. They are suns, separated by vast distances, embedded in a structure larger than any early observer could imagine. This growth in understanding does not require abandoning wonder. It deepens it. The universe becomes quieter and more expansive, governed by regularity rather than enclosure. The sky no longer presses close. It opens outward. As you rest with this history, you notice a pattern. Limits feel natural until measurement dissolves them. What once felt final becomes provisional. Understanding advances not by reaching an edge, but by realizing there is none to reach. This realization settles gently. The measured cosmos does not overwhelm. It reassures. It shows that reality is consistent, even when vast. The sky above remains the same, yet it now carries depth rather than enclosure. And in that depth, curiosity continues to find room to breathe, guided by observation rather than expectation. When physics speaks about space, it does so carefully without imagery or assumption. Space is not treated as a thing you can touch or fill. It is described as a structure that allows positions to be defined and distances to be measured. This difference matters. Space is not an object within the universe. It is the framework within which objects are located. You can feel how different this is from everyday experience. In daily life, space feels like an empty container, something waiting to be filled. A room feels empty until furniture is placed inside it. But physics does not rely on this intuition. In scientific terms, space exists whether or not it contains matter. In classical physics, space is continuous. Between any 2 points, no matter how close, there is always another point in between. There are no gaps. This continuity allows motion to be described smoothly and predictably. Objects move through space along paths that can be calculated and measured. Space is also uniform. The laws of physics work the same way in one location as they do in another. There is no preferred direction or special position built into space itself. This principle is confirmed through countless experiments. No matter where measurements are made, the same physical relationships appear. Because of this uniformity, space does not behave like a surface with an edge. A surface has boundaries because it exists within a larger environment. Space does not. There is no higher dimensional container that space sits inside, at least none that physics can describe or measure. Asking what lies beyond space is like asking what lies north of the North Pole. The question does not correspond to a physical direction. This idea can feel subtle at first. Your mind wants to imagine space as something extended within something larger. That instinct comes from everyday objects. Every container you know exists within another space. Physics asks you to release that assumption, gently and without urgency. Coordinates help clarify this. When physicists describe space, they assign coordinates to positions. These coordinates do not mark absolute locations. They describe relationships between objects. Distance becomes a comparison, not a standalone feature. Space is defined through how things are arranged, not through an underlying substance. You can notice how calm this framework feels. Nothing is hidden. Nothing is assumed without evidence. Space behaves consistently, and that consistency is what gives it meaning. The equations do not ask where space ends, because nothing in the measurements suggests an ending. Light offers further clarity. Light travels through space at a constant speed, the same in all directions. This has been tested with extreme precision. If space had edges or special regions, light would behave differently near them. No such behavior is observed. Instead, light continues until it interacts with matter or spreads thinly across distance. Fading does not signal a boundary. It signals dispersion. The absence of light does not mean the absence of space. It simply means there is nothing emitting light there. This distinction is important. Darkness is not a wall. Silence is not an edge. Space does not announce itself through sensation. It reveals itself through measurement. Where there are distances to measure, space is present. You can feel how this reframes earlier intuitions. The sky does not feel like a dome because it truly is one. It feels that way because depth is difficult to perceive without motion or reference. Physics replaces this impression with careful inference. As scientific tools improve, this inference becomes stronger. Telescopes see farther, not because space opens, but because sensitivity increases. There is no point at which observations suddenly fail due to a physical barrier. They fade gradually as signals weaken. Space also does not push back. It offers no resistance to motion. Objects move through it according to forces, not because space allows or forbids passage. This absence of resistance supports the idea that space is not a medium in the everyday sense. Historically, some scientists imagine space as filled with a subtle substance. These ideas are tested and abandoned when evidence fails to support them. What remains is a simpler description. Space is the set of relations that make motion and distance meaningful. This simplicity does not mean emptiness. Space can contain fields, energy, and matter. But these are contents, not space itself. Removing all contents does not remove space. Measurements can still be defined. Positions can still be described. As you rest with this understanding, the need for an edge quietly dissolves. Edges belong to objects within space. They mark transitions from one substance to another. Space does not transition into something else. It simply continues as long as relationships can be defined. Your intuition may still search for closure, and that is natural. Physics does not ask you to abandon intuition. It asks only that intuition not be mistaken for evidence. Where evidence speaks clearly, understanding can follow calmly. The idea settles without effort. Space does not require boundaries to exist. It requires consistency, measurability, and structure. These are present everywhere observation reaches. The feeling of enclosure belongs to perception, not to physics. As thought slows, the framework becomes familiar. Space is not something you fall into or press against. It is the quiet order that allows everything to be where it is. And within that order, motion, distance, and time find meaning, without needing an edge to hold them in place. You are used to thinking of space and time as separate. Space feels like where things are. Time feels like when things happen. In everyday life, this separation works well. You move through space as time passes, and the two feel independent. Physics, however, reveals something quieter and more precise. Space and time are woven together into a single structure. This idea does not come from imagination. It comes from measurement. When scientists study how light moves and how clocks behave, they find patterns that cannot be explained if space and time are treated as unrelated. The same experiments, repeated in different places and at different speeds, point toward a deeper connection. Light plays a central role. Light always travels at the same speed, no matter how fast the source or the observer is moving. This result is not intuitive, but it is confirmed again and again. To preserve this consistency, measurements of space and time must adjust together. Distances and durations change depending on motion, but the speed of light remains fixed. This adjustment is subtle. At everyday speeds, the effect is too small to notice. Clocks tick almost identically. Rulers measure nearly the same length. Life proceeds without disruption. Yet precision instruments reveal the change. Time slows slightly for fast-moving clocks. Length contracts slightly along the direction of motion. These are not illusions. They are measurable facts. The connection deepens with gravity. Gravity is not treated as a force pulling objects through space. Instead, gravity arises from the shape of the combined structure of space and time. Massive objects change this structure. They alter how distances and durations relate. Objects follow these changes naturally, moving along paths shaped by the geometry around them. You can think of this without imagery. Measurements near massive objects differ from measurements far away. Clocks closer to mass run more slowly than clocks farther away. This difference is small but precise. Satellites must correct for it to function properly. Without accounting for this effect, navigation systems would drift and fail. These corrections are not theoretical. They are applied daily. The agreement between prediction and observation is exact. This agreement tells you something important. Space and time are not passive backgrounds. They participate in physical processes. They respond to energy and mass in predictable ways. This unified structure is called spacetime. The name reflects its nature. It is not space plus time. It is a single entity with 4 dimensions, 3 associated with location and 1 with duration. Events are not described by where they happen alone, or when they happen alone, but by both together. Within this framework, motion becomes relative rather than absolute. There is no universal clock ticking the same for everyone. There is no fixed grid defining rest. Each observer measures space and time according to their state of motion. Yet the underlying laws remain the same. This consistency is what allows agreement despite difference. You may notice how calm this structure feels. Nothing is arbitrary. Nothing changes without cause. The relationships adjust smoothly, preserving deeper invariance. The universe remains orderly even as perspectives differ. This union also removes the need for a preferred center. There is no single reference point where time flows correctly and space is perfectly still. Every observer carries their own measurements, all equally valid within the same physical laws. Reality does not privilege one viewpoint over another. Because of this, spacetime does not require boundaries. Boundaries imply a surrounding environment or a reference frame beyond the system. Spacetime contains all frames within itself. There is no external clock or ruler against which it must be compared. You might feel the quiet elegance in this. By uniting space and time, physics simplifies rather than complicates. Gravity becomes geometry. Motion becomes relationship. Consistency replaces absolute structure. As measurements extend outward, this structure remains intact. Light from distant galaxies obeys the same rules. Clocks in deep space follow the same relationships. No observation suggests a breakdown or an edge where spacetime fails to apply. Even when spacetime curves strongly near dense objects, the equations continue to work. Paths bend. Time stretches. Yet the framework holds. The union remains stable across extreme conditions. This stability allows cosmology to describe large-scale behavior. Expansion, motion, and gravity all emerge from the same underlying structure. There is no need to imagine space stretching through time or time flowing through space separately. They evolve together. You may notice how this understanding softens earlier questions. If space and time are one structure, asking where space ends becomes less meaningful. An ending would require a condition where relationships stop applying. No evidence points to such a place. As your breathing remains slow, the idea settles gently. The universe does not rush. Measurements unfold calmly. The union of space and time provides coherence without confinement. You do not need to visualize this structure. You only need to accept that measurements reveal it. Reality is consistent, even when intuition struggles. Precision replaces guesswork. The awareness becomes quiet and steady. Space and time are no longer separate stages. They are aspects of the same fabric of measurement, responding together to motion and mass. And within this union, the universe continues smoothly, without pause, without boundary, following rules that remain reliable wherever observation can reach. As you rest with the idea of spacetime as a unified structure, attention turns to how that structure behaves on the largest scales. One of the most important discoveries in modern astronomy is that distances between galaxies are increasing over time. This is not inferred from theory alone. It is observed directly, through light that has traveled across immense stretches of space. When astronomers analyze light from distant galaxies, they notice a consistent pattern. The light is shifted toward longer wavelengths, a phenomenon known as redshift. This shift is not random. The farther away a galaxy is, the more its light is stretched. The simplest and most accurate explanation is that space itself is expanding as the light travels through it. This expansion does not resemble an explosion. There is no central point from which everything moves outward. Instead, every large region sees other regions moving away. From any galaxy, all distant galaxies appear to recede. This symmetry is observed everywhere measurement is possible. You can consider a simple analogy used carefully. Imagine points drawn on a surface that stretches uniformly. As the surface grows, the points move farther apart, even though none of them is at the center. The surface does not expand into a surrounding space. The distances within it simply increase. This analogy does not describe all aspects of the universe, but it helps clarify one key idea. Expansion does not require an edge. In the universe, expansion occurs within spacetime itself. There is no surrounding emptiness that space grows into. The structure of spacetime changes so that distances between distant objects increase over time. Locally, where gravity binds systems together, this expansion is negligible. Galaxies, solar systems, and atoms remain intact. This distinction matters. Expansion does not pull objects apart against strong forces. It becomes noticeable only across vast distances where gravity is weak. This behavior is consistent with observation. Nearby galaxies move under gravitational influence. Very distant galaxies show systematic recession due to expansion. The absence of an edge follows naturally from this behavior. If expansion occurred from a central point into pre-existing space, there would be a detectable difference between directions. Observations show none. The universe appears statistically similar in all directions, a property supported by measurements of background radiation and galaxy distribution. You may notice how calmly this resolves earlier intuition. Expansion does not imply a growing bubble with a surface. There is no outer shell. The universe is not swelling into something else. Distances increase because the metric, the way spacetime measures separation, changes uniformly. This understanding also clarifies the idea of limits. There is a region beyond which light has not yet had time to reach you. This boundary is called the observable universe. It is not a physical wall. It is a horizon defined by the finite speed of light and the finite age of the universe. Beyond this horizon, space continues to exist. Galaxies may be present. The laws of physics remain the same. They are simply not observable from your location, because their light has not arrived. The horizon marks the limit of observation, not the limit of reality. As time passes, this horizon changes. Light from slightly farther regions reaches you. The observable universe grows. Yet even this growth does not reveal an edge. Each new layer opens onto more space, consistent with what came before. Measurements of cosmic background radiation support this picture. This radiation comes from an early stage of the universe and arrives from all directions with remarkable uniformity. Small variations encode information about early conditions, but no direction shows signs of proximity to a boundary. This uniformity is one of the strongest pieces of evidence for expansion without an edge. If the universe had a nearby boundary, it would leave an imprint. No such imprint is found. Instead, observations match predictions of a universe that expands evenly everywhere. The concept may feel counterintuitive because expansion in daily life always involves surroundings. Objects expand into air or vacuum. The universe does not behave this way. There is no external reference frame to expand into. The change happens internally, within the relationships that define distance. You do not need to visualize this fully. The brain is not designed for it. It is enough to trust measurement. Expansion is detected through precise shifts in light. These shifts behave exactly as predicted by models of expanding spacetime. As breathing remains slow, the idea becomes less demanding. The universe grows larger without approaching a boundary. Space stretches without thinning into nothing. There is no approaching edge to collide with or fall past. This realization removes a quiet tension. Expansion does not imply fragility or instability. It is a smooth, measured process, unfolding according to well-tested laws. The same rules apply everywhere observation reaches. In this calm understanding, the universe feels less like a container and more like a continuous structure. It does not need walls to define it. It needs only consistent relationships that can be measured and confirmed. You rest with this knowledge gently. Vastness does not require borders. Growth does not require an outside. Expansion happens without edges, quietly and evenly, carrying galaxies apart while preserving the deep order that measurement reveals. As you settle into stillness, it becomes important to separate two ideas that sound similar but mean very different things. One is the observable universe. The other is the universe as a whole. The distinction between them is quiet, precise, and central to understanding why reality feels limited even when it may not be. The observable universe is defined by light. Light travels at a finite speed, and the universe has existed for a finite amount of time. Because of this, There is a maximum distance from which light has been able to reach you since cosmic history began. Everything within that distance is observable. Everything beyond it is not. This limit is not marked by a wall or surface. It is not a place where space ends. It is simply the farthest distance from which information has had enough time to arrive. The boundary exists in time, not in space itself. You can feel how different this is from everyday limits. When you reach the edge of a room, the wall is physically there. When you reach the edge of observation, nothing blocks you. There is only silence because no signal has yet arrived. As the universe ages, this observable region changes. Light that was once too far away eventually reaches closer observers. The observable universe grows, not because space expands into something new, but because more time allows more information to arrive. This growth is gentle and predictable. It does not reveal an edge. Each new layer of observation shows more of the same large-scale structure. Galaxies continue. Space behaves consistently. There is no sudden transition that suggests a boundary is near. The existence of an observable limit can easily be mistaken for an actual edge. Your intuition may say that if you cannot see beyond a point, nothing exists there. Science encourages a calmer interpretation. Absence of evidence is not evidence of absence, especially when absence is explained by known physical limits. Astronomers rely on this distinction constantly. When they observe distant objects, they understand that what they see is a record of the past. Light from distant galaxies began its journey billions of years ago. Observation becomes a form of time travel, not exploration of an outer region. This perspective changes how limits are understood. The observable universe is not the maximum size of space. It is the maximum distance back in time that observation allows. Space itself may continue far beyond this horizon, shaped by the same laws. Measurements support this view. The distribution of galaxies and background radiation appears uniform near the observable boundary. There is no sign that structure changes abruptly. This uniformity suggests that what lies beyond is likely similar, not fundamentally different. Cosmological models use this evidence carefully. They do not claim certainty about what lies beyond observation. They simply note that nothing observed suggests a nearby end. The simplest explanation, consistent with all data, is that space extends well beyond the observable region. You may notice how calm this reasoning is. There is no dramatic assertion. There is no need to imagine unseen regions in detail. Science remains quiet and conservative, guided by what is measured and what would be detectable if present. The concept of a horizon helps clarify this. A horizon marks the limit of what can influence you, not the limit of existence. In daily life, a horizon hides land beyond sight, not because it ends, but because Earth curves away. The cosmic horizon functions similarly, though for different physical reasons. This understanding allows you to relax the idea that observation defines reality. Reality continues whether or not it is witnessed. Science accepts this calmly, relying on consistency and evidence rather than sensation. As you breathe slowly, the distinction becomes gentle and intuitive. The observable universe feels like a window, not a container. It frames what can be seen, not what exists. This framing explains why the universe feels finite. Your experience is limited to what light has delivered. Everything beyond remains unseen, not absent. The feeling of enclosure arises naturally from this informational boundary. Technology extends the window, but never removes it completely. No matter how powerful instruments become, they remain bound by the speed of light and the age of the universe. Observation will always have limits, even if reality does not. This is not a failure of science. It is an honest feature of how knowledge works. Knowing where limits lie is itself a form of understanding. It prevents confusion between what is unreachable and what is non-existent. As awareness softens, the idea settles comfortably. The universe does not need to be fully seen to be whole. The unseen does not threaten understanding. It simply lies beyond current reach. You rest with the sense that reality is larger than perception, yet consistent with everything measured so far. The observable universe provides a reliable picture without claiming completeness. And within that quiet balance, curiosity remains calm, open, and unhurried, supported by the knowledge that limits of sight are not limits of existence. When you think about shape, the mind often looks for edges. Most objects you interact with have boundaries you can touch or see. A table has sides. A book has covers. Even open spaces like fields eventually give way to something else. Geometry, however, allows for shapes that behave very differently from everyday objects. In mathematics and physics, geometry describes how distances and angles behave, not what something looks like. This distinction is important. A shape does not need to sit inside a larger space to be defined. It only needs rules that describe how points relate to one another. One of the simplest examples is the surface of a sphere. If you move in a straight line on a sphere's surface, you never encounter an edge. There is no boundary to cross. Yet the surface is finite. It has a total area that can be measured precisely. This combination of finiteness without boundaries is not imagined. It is exact, testable, and familiar. You have experienced this without realizing it. Traveling on Earth, you can move continuously in one direction and eventually return to your starting point without ever meeting an edge. The surface does not end, even though it does not extend infinitely. Geometry allows this naturally. This idea becomes powerful when applied to space itself. Cosmology asks how distances behave on the largest scales. Do parallel lines remain parallel forever? Do angles in large triangles add up exactly as expected? These questions are not abstract. They are answered through observation. Different geometries describe different behaviors. In flat geometry, the kind learned in school, parallel lines never meet, and angles of a triangle add up to 180 degrees. In positively curved geometry, lines eventually converge, and angles add up to more than 180 degrees. In negatively curved geometry, lines diverge, and angles add up to less. Each of these geometries is internally consistent. None requires an edge. The differences lie in how space responds to distance. Curvature is not something imposed from outside. It is a property of the geometry itself. When physicists study the universe, they measure curvature by observing large-scale patterns. They look at the distribution of galaxies and the structure of background radiation. They analyze how light travels over vast distances. These measurements reveal how space behaves, not what it looks like. So far, the results are calm and consistent. On the largest observable scales, space appears very close to flat. This does not mean it is exactly flat everywhere. It means that any curvature is too small to detect with current instruments. The universe behaves, within measurement limits, like a geometry without noticeable curvature. Even so, flat geometry does not imply boundaries. A flat space can extend infinitely, or it can loop back on itself in subtle ways that preserve flatness locally while remaining finite overall. Geometry allows both possibilities without contradiction. What matters is that no measurement reveals an edge. Light travels smoothly. Angles behave predictably. Distances increase uniformly with expansion. There is no region where geometry breaks down or signals a boundary. This understanding helps calm earlier intuitions. The absence of an edge is not mysterious. It is a natural outcome of how geometry works when freed from everyday assumptions. Edges belong to objects embedded in space, not to space itself. You may notice how gently this idea settles. Geometry does not argue. It describes. It tells you how measurements relate, not how reality should feel. When geometry allows space to be unbounded, physics listens. This approach removes the need for speculation. There is no requirement to imagine what lies beyond an edge, because the concept of an edge does not apply. Space does not need to be surrounded by something else to have shape. As you breathe slowly, the idea becomes familiar. Shape does not always mean enclosure. Finite does not always mean bounded. Geometry offers a language that fits observation without forcing intuition to lead. This language is quiet and precise. It allows cosmology to remain grounded in evidence. Models are chosen not because they feel right, but because they match what is measured. So far, measurements favor a universe whose geometry does not announce an ending. You rest with the thought that space can be complete without being closed off. Geometry provides this possibility naturally, without adding assumptions. It does not stretch imagination. It replaces it with consistency. In this calm understanding, boundaries lose their urgency. The universe does not need edges to define itself. It is defined by relationships, distances, and the way those distances behave across vast scales. As awareness softens, geometry feels less abstract. It becomes a quiet guide, showing how reality can be whole without being enclosed. Space remains open, measured, and consistent, shaped by rules that require no borders to hold them together. The idea of infinity often arrives quietly, without sound or image, yet it creates tension almost immediately. You may notice it as a subtle discomfort, a sense that thought has reached a place where it cannot rest. Infinity feels different from large numbers or distant places. It does not simply extend understanding. It removes the possibility of completion. This reaction is not mysterious. The human mind evolves to handle tasks that end. Every action you take has a beginning and a conclusion. You reach a destination. You finish a meal. You complete a day. These cycles shape expectation. Completion brings resolution, and resolution brings calm. Infinity offers no such resolution. It cannot be crossed, finished, or contained. There is no final point where effort stops. For a brain designed to anticipate outcomes, this absence feels unstable. The discomfort arises not from danger, but from unfamiliar structure. Neuroscience shows that the brain processes quantity by comparison. Small numbers are understood through direct perception. Larger numbers are understood symbolically. At some point, quantity stops feeling distinct. Beyond that point, difference becomes abstract rather than sensed. You can notice this easily. The difference between 1 and 2 feels immediate. The difference between 1 million and 2 million does not. Infinity sits far beyond this threshold. It is not larger in a way the brain can register. It is different in kind. Infinity is a concept, not an experience. No one has perceived infinity directly. It exists within mathematics as a tool for describing behavior that does not terminate. In physics, it often signals limits of a model rather than a physical object. Yet when infinity appears in descriptions of space, the mind treats it as something to imagine. This creates strain. Imagination relies on images and boundaries. Infinity provides neither. Thought searches for edges and finds none. The brain responds by seeking closure. It may imagine a distant wall, a final surface, or a boundary beyond which nothing exists. These images bring relief, even if they conflict with scientific understanding. They satisfy cognitive expectation. This is why unbounded space feels unsettling. It denies the brain its usual anchors. There is no frame to lean against, no final marker to complete the picture. The mind remains active, scanning for structure that is not required. Science does not ask the brain to feel comfortable with infinity. It asks only that discomfort not be mistaken for evidence. Feelings reveal how cognition works, not how reality is shaped. When physicists describe space as infinite, they do not mean endless in a dramatic sense. They mean that no boundary has been detected and no measurement requires one. Infinity becomes a statement about absence of limits, not about overwhelming size. This subtlety matters. Infinity is not a place you could reach if you traveled long enough. It is a description of behavior. Space does not stop. Distances can continue increasing without encountering an edge. Mathematics handles this calmly. In math, infinity is well defined. It follows rules, produces consistent results. The unease felt by the mind does not affect its validity. Mathematics does not require intuition to agree. Physics uses this mathematical calm carefully. When infinity appears, scientists test whether it reflects reality or a limitation of description. Many infinities disappear when models improve. Others remain as indicators that space or time does not terminate. Your discomfort, then, becomes informative. It reveals the boundary between perception and abstraction. The brain resists infinity because it cannot simulate it. That resistance does not imply error in the concept. As you breathe slowly, you may notice that the discomfort softens when you stop trying to picture infinity. You do not need to imagine endlessness. You only need to accept that not all truths are visual or experiential. This acceptance brings quiet. Infinity does not need to be felt to be understood. It can remain a property of equations and measurements, held lightly rather than visualized. You are not required to resolve infinity emotionally. Understanding does not demand comfort. It asks only for clarity about where intuition applies and where it does not. As thought settles, infinity becomes less intrusive. It no longer presses against imagination. It simply exists as a description of how space behaves when no boundary is present. This calm does not erase mystery. It reframes it. Mystery becomes something to acknowledge rather than resist. The universe does not owe the mind a shape it can hold. In this quiet awareness, unease transforms into neutrality. Infinity stops feeling threatening and starts feeling distant, abstract, and stable. It no longer needs to be conquered or visualized. You rest with the understanding that discomfort arises naturally when cognition meets unfamiliar scale. It is not a warning. It is a signal that knowledge has moved beyond instinct. And in that space where feeling yields gently to understanding, the mind can relax, allowing reality to be larger than comfort, yet no less calm or consistent because of it. Time feels personal. You sense it passing through changes in light, in sound, in your own body. A moment begins, unfolds, and ends. Days close into nights. Seasons replace one another. This rhythm feels so fundamental that it seems impossible to imagine time without an ending. Your experience of time is shaped by duration. You measure it through processes. A breath lasts a few seconds. Sleep lasts hours. A life unfolds across decades. Every meaningful unit of time you know has a beginning and a conclusion. This pattern becomes expectation. Biology reinforces this expectation. Your body follows cycles that repeat and resolve. Hunger rises and falls. Fatigue builds and releases. Even attention moves in arcs, focusing and relaxing. These rhythms give time structure. They make it navigable. Because of this, time feels like a flow moving toward completion. You wake, you act, you rest. The cycle resets. When something interrupts this pattern, it stands out. Endings become markers of meaning. Physics approaches time differently. In scientific measurement, time is not something that flows. It is a dimension used to order events. A clock does not feel time passing. It records consistent intervals based on physical processes. The ticking is not time itself. It is motion used as a reference. This distinction matters. When physicists describe time, they do not assign it intention or direction. They describe relationships between events. One event happens before another. Two events occur simultaneously for one observer and not for another. These relationships are measurable and precise. The feeling of time moving forward comes from change. When nothing changes, time leaves no trace in experience. Memory records differences, not duration itself. Without change, time would be imperceptible. This explains why still moments feel timeless. When the environment remains quiet and the body rests, fewer changes are recorded. Time seems to slow, even though clocks continue steadily. Experience and measurement diverge gently. The expectation of an end arises from this experience-based understanding. If all processes you know conclude, it feels natural that time itself should do the same. A final moment feels like a logical extension of familiar patterns. Cosmology complicates this intuition. The equations that describe time do not require a stopping point. Time is measured relative to events, not toward a destination. As long as events can occur, time can be defined. Even the beginning of cosmic history does not behave like an edge in time. It marks a limit to current understanding, not a known final or absolute origin. Physics describes what happens after a certain point with confidence. Before that, models remain incomplete. This uncertainty does not imply an ending or a beginning in the everyday sense. It reflects limits of description. Time itself does not announce boundaries. Only knowledge does. You may notice how similar this is to space. The feeling that time must end mirrors the feeling that space must end. Both arise from lived experience. Both fade when measurement replaces intuition. The future often feels more open than the past, but this is a psychological feature, not a physical one. Memory fixes the past. Possibility stretches ahead. Physics treats both directions symmetrically in many equations. The sense of flow comes from entropy, the tendency for systems to move toward states of greater disorder. Entropy gives time direction in experience. Processes leave traces. Cups break and do not unbreak. Heat spreads rather than concentrates. These asymmetries shape memory and expectation. They make the future feel different from the past. Yet entropy does not require time to end. It describes change within time. Even if conditions evolve, the dimension itself remains available for events to be ordered. This understanding softens the need for a final moment. Time does not need a conclusion to be meaningful. Meaning arises locally, within processes and experiences, not from the total span. As you breathe quietly, the pressure for time to resolve begins to ease. The mind can rest without knowing how long time lasts. It does not need to picture an ending to function. Physics offers calm reassurance here. Equations remain valid without requiring a final tick. Observations show consistency across immense durations. No signal suggests time is approaching exhaustion. The feeling of an end belongs to stories, not to measurement. Stories require structure. They begin and end to be understood. Reality does not follow narrative rules. This does not make reality cold or empty. It makes it stable. Time continues to provide order without demanding closure. Events unfold. Relationships persist. You can allow this idea to settle gently. Time does not rush toward a finish. It remains available wherever change can occur. The universe does not count down. As thought slows, the sense of urgency fades. The present moment becomes sufficient. Time is no longer something to reach the end of. It is simply the dimension in which experience unfolds. In this calm awareness, the feeling of an ending loosens its grip. Time stretches without pressure, measured without intention, continuing quietly as long as events can be distinguished from one another, offering order without demanding a final moment of release. Understanding the universe does not begin with imagination. It begins with measurement. Long before explanations are offered, something is observed, recorded, and compared. This quiet process forms the foundation of science. It is slower than intuition, but far more reliable. Measurement turns experience into information. A distance becomes a number. A duration becomes an interval. Light becomes a wavelength. These quantities can be tested, repeated, and checked by others. They do not depend on how something feels, only on how it behaves. You may notice how different this is from everyday knowing. In daily life, you trust perception. If something looks close, it usually is. If time feels long, it usually has been. Science begins where this trust becomes unreliable. It asks not how something seems, but how it can be measured. From measurement, models emerge. A model is not a picture of reality. It is a structured description that connects quantities in a consistent way. It tells you how one measurement relates to another. If this relationship holds across many situations, the model earns trust. This distinction matters deeply. When a model describes space as unbounded, it does not claim to show what space looks like. It describes how distances behave when measured. When a model describes time as relative, it does not say how time should feel. It explains how clocks behave under motion and gravity. Models are judged by prediction. If a model allows scientists to calculate outcomes that later match observation, it remains useful. If it fails, it is revised or replaced. This process is continuous and calm. No model is sacred. Only consistency with evidence matters. You can see this clearly in astronomy. Distances to stars are not guessed. They are measured through parallax, brightness, and motion. Each method builds on another. When results agree, confidence grows. When they differ, uncertainty is acknowledged openly. This openness is a strength, not a weakness. Science does not require certainty to function. It requires honesty about limits. A model may work well within a range and fail beyond it. This failure does not mean reality breaks. It means description needs refinement. Infinity often appears at these boundaries. When a model predicts infinite values, scientists do not immediately accept them as physical truth. They ask whether the model is being pushed beyond its valid range. Many infinities disappear when better models replace older ones. Yet some remain meaningful. An infinite extent may simply indicate that no boundary has been detected. Measurement does not find an end, so the model reflects that absence. Infinity becomes a statement about lack of evidence for limits, not about unreachable extremes. You may notice how gently this reframes earlier discomfort. The universe is not described as infinite because it overwhelms thought. It is described that way because measurement does not reveal an edge. The model remains open because observation remains open. This approach also explains why different models can coexist. At small scales, one set of equations works well. At large scales, another applies. Neither claims to be the final picture. Each is a tool suited to its domain. This layered understanding allows science to progress without contradiction. Models overlap where they agree and give way where they fail. Reality remains consistent even as descriptions evolve. As you rest with this idea, you may feel intuition loosening its hold. The need for reality to match expectation softens. Measurement offers a steadier guide. It does not demand belief. It earns trust through repetition. The role of models is not to comfort. It is to clarify. They strip away assumptions and leave only relationships that can be tested. In doing so, they often challenge how things feel. This challenge is not a flaw. It is a feature of learning. When a model suggests that space has no edge, it does not ask you to imagine endlessness. It asks you to accept that no measurement contradicts continuation. When a model describes time without a final moment, it does not deny endings in experience. It simply shows that time itself does not require one. You can allow this understanding to settle slowly. Science does not replace perception. It extends it. It reaches beyond what senses evolve to handle and returns with patterns that remain consistent. This consistency is deeply calming. It means reality behaves lawfully, even when unfamiliar. It means questions are answered with care rather than assumption. It means uncertainty is acknowledged without fear. As breathing remains slow, the idea becomes reassuring. Models are not rigid truths. They are flexible guides, refined as knowledge grows. They do not trap understanding. They free it from the limits of intuition. You rest knowing that the universe is not known through feeling alone. It is known through patient measurement, shared verification, and models that remain open to revision. This process does not rush. It does not close questions prematurely. In this quiet trust, reality feels less demanding. It does not require complete understanding to be stable. It allows knowledge to deepen gradually, guided by evidence rather than expectation, offering clarity without insisting on final answers, and order without needing to feel complete. There is a quiet strength in knowing exactly where understanding stands. Science does not aim to fill every gap with answers. It aims to describe reality as accurately as evidence allows, and to stop where evidence ends. This balance between knowledge and uncertainty is one of its most reliable features. There are many things known with extraordinary confidence. The expansion of the universe is measured through multiple independent methods. The behavior of light, gravity, and motion is described by equations that have been tested repeatedly. Predictions based on these equations match observation with remarkable precision. You can rest in the solidity of this foundation. These are not ideas held lightly. They are supported by decades of measurement, cross-checking, and refinement. When scientists speak with confidence about these principles, it is because disagreement would require evidence that has not appeared. At the same time, science is careful not to extend certainty beyond what is justified. There are questions that remain open, not because they are ignored, but because current tools cannot yet resolve them. This honesty preserves clarity. For example, the overall size of the universe is not known. It may be infinite or it may be finite without boundaries. Observations so far cannot distinguish between these possibilities. What is known is that no edge has been detected and no measurement requires one. This distinction matters. Not knowing the total size does not undermine what is known about expansion, geometry, or spacetime behavior within the observable region. The local rules remain stable regardless of the global answer. Similarly, the earliest moments of cosmic history remain only partially understood. Equations describe behavior after a certain point with confidence. Before that, conditions become extreme enough that current models lose reliability. This does not mean physics fails. It means it reaches the edge of tested description. You may notice how different this is from everyday uncertainty. Scientific uncertainty is not confusion. It is clearly defined. It marks where evidence ends and where speculation would begin. By stopping at that line, science avoids misleading conclusions. Dark matter and dark energy offer another example. Their effects are measured precisely. Their influence on motion and expansion is clear. What they are made of remains unknown. Science separates these facts carefully. Effects are accepted. Nature is still under investigation. This separation allows progress without illusion. Understanding deepens without pretending to be complete. Knowledge grows in layers, each supported by evidence. You might notice how calm this approach feels. There is no urgency to answer everything. There is no fear in admitting uncertainty. The universe does not become unstable because some questions remain open. In fact, uncertainty plays an essential role. It guides investigation. It highlights where new tools are needed. Prevents overconfidence. Without uncertainty, science would stagnate. At the same time, uncertainty does not weaken what is already known. The behavior of gravity, light, and spacetime is not threatened by unanswered questions about their deepest origins. These frameworks remain reliable wherever they are tested. You can think of knowledge as a map with clear regions and undefined edges. The mapped regions are detailed and trustworthy. The undefined areas are marked honestly, without false detail. The map remains useful precisely because it does not invent terrain. This clarity helps resolve earlier discomfort. The feeling that reality should be fully known is emotional, not scientific. Nature does not require completion to be stable. It unfolds according to laws whether or not they are fully understood. Science does not promise final answers. Promises careful ones. It replaces certainty with confidence where justified, and replaces ignorance with curiosity where needed. As you breathe slowly, this balance becomes reassuring. Reality is not fragile because some things are unknown. It is robust because what is known remains consistent across observation. The unknown does not press inward. It simply exists beyond current reach. There is no indication that it contradicts what has already been measured. The universe has not surprised science by breaking its own rules. This trust is earned, not assumed. Every major discovery is tested against existing frameworks. When adjustments are needed, they are made carefully. When consistency holds, confidence grows. You rest with the understanding that science does not claim ownership of reality. It offers descriptions that improve over time. It does not rush toward closure. It remains open, patient, and precise. In this openness, there is room for calm. You do not need all answers to feel secure. You do not need a final explanation to rest. What is known provides stability. What is unknown provides direction. Together, they form a complete approach to understanding without demanding completeness itself. As thought slows, the boundary between knowing and not knowing becomes gentle rather than sharp. It is not a wall. It is a horizon of inquiry, shifting slowly as tools improve. You remain grounded in what is measured, while allowing unanswered questions to remain unanswered without tension. Reality does not become less real because it is not fully explained. And in this quiet acceptance, understanding feels lighter. Knowledge holds firm where it should, and releases where it must, allowing the universe to remain vast, ordered, and calmly open to discovery, without requiring certainty to be whole. You return now to where you began, not by retracing steps, but by letting understanding settle into familiarity. The universe may extend without edges, but your life unfolds within a space that feels contained, reliable, and calm. This is not a contradiction. It is how reality is lived. You wake each day within a limited environment. Your body occupies a small region of space. Your senses gather information from nearby surfaces, sounds, and light. These limits are not weaknesses. They are what allow focus, attention, and meaning to exist at all. Unbounded reality does not demand that you feel its full scale. Space can extend beyond all measurement, and still your room remains quiet and sufficient. The universe does not intrude. It supports. Science does not ask you to live at cosmic scale. It asks only that you understand where perception applies and where it does not. You are not required to imagine infinity in order to exist peacefully within it. This realization brings relief. The universe does not press its vastness into daily life. It allows human experience to remain local, slow, and grounded. The same laws that govern distant galaxies also govern the steady fall of breath and the rhythm of the heart. You may notice how this continuity feels reassuring. There is no sudden shift between the familiar and the cosmic. The physics that describes expansion and spacetime also describes the motion of your body and the passage of time around you. Unbounded space does not remove orientation. You still know where you are. You still know what matters. Direction and distance remain meaningful at human scales, even if they lose meaning at larger ones. This coexistence is quiet and stable. Reality does not ask to be felt all at once. It allows understanding to arrive gradually, in forms suited to experience. You can hold the idea of an unbounded universe lightly. It does not need to dominate thought. It does not need to be resolved emotionally. It can remain a background truth, like gravity or time, shaping existence without demanding attention. In this way, science becomes a source of calm rather than disturbance. It removes false constraints without imposing new ones. It shows that lack of boundaries does not imply chaos. It implies consistency without enclosure. You may notice that fear often comes from imagining edges or endings. A final wall, a last moment. Unbounded reality offers something quieter. It removes the pressure for completion. There is no approaching limit that must be reached or feared. Life unfolds within finite intervals, and that is enough. Meaning arises from relationships, not from total extent. A conversation matters even if space has no end. Rest matters even if time continues. This understanding does not diminish human experience. It places it gently within a larger context, without demanding that it carry cosmic weight. You are not responsible for the universe's size. You are only present within it. As breathing slows, the idea settles deeper. Reality does not need to feel infinite to be infinite. It does not need to feel unbounded to be unbounded. Feeling and structure operate at different levels, each appropriate to its role. Science clarifies structure. Experience provides feeling. Neither replaces the other. Together, they allow understanding without strain. You can let curiosity remain soft. There is no urgency to know everything. There is no threat in not knowing. The universe continues whether or not it is fully understood. This quiet continuation mirrors your own rest. While you sleep, the world does not pause. Processes continue calmly. Motion persists. Order remains. You do not need to supervise it. In the same way, the unbounded universe does not require constant awareness. It holds itself together through consistent laws, not through attention. You rest within these laws effortlessly. Gravity holds you gently. Time orders events quietly. Space allows presence without pressure. The feeling of finiteness remains, and that is natural. It belongs to lived experience. It does not contradict the larger reality that science describes. Both are true at their own scales. As thought softens, the need to reconcile everything fades. Understanding does not require resolution at every level. It requires trust where evidence is strong, and patience where it is not. You are allowed to rest inside an unbounded reality without carrying its weight. You are allowed to sleep while space extends and time unfolds. The universe does not rush. It does not demand conclusion. It remains open, measured, and stable, offering structure without enclosure. And within that quiet stability, you remain exactly where you need to be, grounded, finite, and at ease, as reality continues calmly beyond perception, without edges, without urgency, and without disturbing the gentle rhythm of rest.